Find the function that has the solution 4 and 2i. This means that x has to be 0 at 4 and x has to be 0 at 2i. Now, because complex zeros come in conjugate pairs, I know that whatever this function is, it also has to be 0 at negative 2i. To retrieve the function, I'm going to first express the function as its linear factorization, and I can achieve that by rewriting this equation. If I subtract 4 on both sides, I'm going to get x minus 4 equal to 0. Here, if I subtract 2i on both sides, I get x minus 2i equal to 0. And then finally, if I add 2i to both sides, because here I have a negative, I'm going to have to add, I get x plus 2i equal to 0. So I'm going to multiply these binomials together, and that's going to allow me to retrieve the function that has these solutions. So I'm going to begin by grabbing x minus 4, multiplying it with x minus 2i, and then multiplying it with x plus 2i. I'm going to begin to simplify it by first addressing the complex conjugates, because whenever I multiply complex conjugates, I'm just going to add the sum of the squares of the real parts. So here, my first part is x, so I'm going to get x squared, and I'm going to sum that with the real part of negative 2i, which would just be the negative 2. So negative 2 squared. So let me go ahead and write that down. So I get x squared plus negative 2 squared, which is just going to be x squared plus 4, since negative 2 to the second power, that's going to give me a positive 4. I'm going to multiply this x squared plus 4 with this x minus 4. And there's a variety of ways in which I can do this, but I'm going to choose to do it by distribution. So here I'm going to get x and multiply it with x squared to give me x to the third. I'm going to get x and multiply it with 4 to get 4x. And now I'm going to grab the negative 4 and multiply it with x squared to get negative 4x squared. And I'm going to grab the negative 4, multiply it with the positive 4 to get negative 16. The only thing left to do is to write this in standard form, meaning that I have to get the highest power and then write each term in the descending order. So here I'm going to begin by recording x to the third, followed by negative 4x to the second power, followed by positive 4x and negative 16. And that would be the function that has the zeros at 4 and 2i.